In this video, I will talk about shadowing. First, I will explain what is shadowing in different contexts, including selection construct, if statement, and loops. Next, I will talk about shadowing in member functions. And finally, I will talk about shadowing in inheritance relationship. I am going to be using this code to expand it further and explain the concepts. First, what is shadowing? It is essentially a process whereby a variable in a smaller scope or narrower scope actually it gets accessed over the variable name with the same scope defined in a broader scope. In other words, a variable in nested scope shadows or makes invisible and another variable with the same name in coming from a broader scope. Let me explain it through the example. I have this skeleton code. In this place, I am going to be defining. Let me define variable x equals to 5 and initialize it to 5. This is the variable which is visible in all the places in the program. If I want to print this variable in this place, it is going to be displayed like this. So first let me compile this code and show you the output. After that I will go further. So to compile this code, I have this file here, main1.cpp, which actually contains the code. G++, I'm going to be using C++23 standard. Output file name is going to be main1.exe and my source file is main1.cpp. So compilation successful. Main1.cpp is going to be executed. It's going to be main1.exe that is going to be executed. So x5 is actually accessed, you can see. Now if I define another variable with the same name in the main function scope, let me make it double, a different type, x equals to 3.66. If I try to access the name x after I define the variable, then this variable which is defined inside in line 11 is going to be accessed, right? That process is called shadowing. We say that the inner variable, the variable defined in the main function scope, actually shadows the variable that was defined in the global scope, right? Let me show you the output. So compilation and execution. Now you can see in the inner space 3.66, the variable that was defined inside the scope is actually accessed. Going back to the code. Now shadowing can also happen from within the scope inside the main function. This is called block scope. You can create a scope by having two curly braces, which is called a block scope. Inside this block scope, if I define a variable with the same name, let's say this time string x equals to 45.66. This is not a number, this is a string. Okay, sequence of characters. So if I try to access x from within, then again this variable x, string variable, will shadow this the function local variable, and it will also shadow the global variable. Compilation and execution. Now you can see this 5.6 is displayed, but it is not a number that was displayed. It was a string, sequence of characters as a string stored in the variable name x that was displayed. Right. So sometimes you may want to you may also think that this block scope is this is not only type of block scope where it can be, the variable can be shadowed. It is also possible that the if statement also has the block scope, right? If for example, if I have this sort of statement and put these things inside, maybe use integer this time, int x equals to 99, let's say, and I want to display. In this case, actually this variable x will shadow the variable, because you know this x variable will not be accessible, they are in different scope, but this x variable will shadow this variable and also this variable, global variable, right? This also applies in the case of loop. Let's say do while loop. I'm putting false here just to make sure that this loop gets executed for only one time. I don't want to continue with this loop. So inside the loop also you can have the variable with the same name. It could be different type. Maybe let me give a different initialized different number to just to see the difference. I mean to be sure that actually it was this line was executed. So let me go back to the execution window and compilation and execution. Now you can see whenever that scope becomes active, then the variable is gets defined, and it shadows the variables coming from the broader scope. So similarly, you can also have in a while loop. For example, if I have for while loop, I cannot use this false or true. If I use false, then it will not enter to the loop into the loop. If I have true, then it will continue. I mean, this is going to be infinite loop. So maybe I can use a variable flag equals to true, and let the program control enter the loop once, and then once it is entered, then just you can set it to false. Now you can have the variable, and then you can have a display function, and you can see that it actually shadows the variable in the global scope. Now let me take you to another topic of this discussion. Now next I'm going to be talking about shadowing in the member functions. So for that I will have to remove this code, make it clean again, and I will consider a class. Let me create it, class name my class. It has integer variable x, public, and a constructor. I'm not going to make a default constructor because in this application that will not be used, not needed. Int a, and initialize x to a, and I'm going to have a function to display the data. Right, just don't forget to put a semicolon at the end of class definition. Now if I display data, this x, the data carried by this member variable x, which is actually usually called as instance variable, data. If I have this function, let me create an object of this class. Initialize to, let's say, 12, and display. Right, so first I'm going to be actually compiling and showing the output, then I will continue from there. So compilation and execution, the data is displayed 12. Right, going back to the code, now this instance variable is accessible, that is obvious to many of you, from the member function, accessible from member function. But if in case I actually define a variable inside the member function, if I define another variable with the same name, now in this case, like in the previous discussion, it actually shadows the instance variable. Right, whenever I try to access data through this variable x, then it will access this double variable, and the data is going to be the data that is initialized in this place. So if I put this output statement after that, from this point to the end of the scope of print function, it will access 3.66. Back to the compilation and execution. Now you can see the data that is printed is 3.66. Right, so this is the shadowing, the local variables of the member function actually shadowing the instance variable. Now I will talk a little bit about how to overcome this shadowing. Sometimes in this place you may want to actually access the instance variable instead of local variable. So it's very easy in this case. In the case of class, the class has something called the pointer to current object, which is called this pointer. So if you have a pointer to current object, then through that pointer you can access instance variable. So if I want to access instance variable in the place where it is shadowed, then I can use this pointer and access x through it. Right, this is the one way of overcoming shadowing in this case. Let me show you. Compilation, execution. Now you can see this instance variable data 12 has been accessed. Right, there is another way of doing that. You can create a reference to the instance variable. For example, in this place, before you actually define, if you create a reference to instance variable, and then you should be able to access the instance variable data through that reference. Right, so this should also display the value 12 on this value. So let me show you the output. Oh, there is a small error, so let me explain what is the error and try to fix it. I'm taking you back to the code. So what it actually is saying is we have this reference, because this function is constant. So if you try to have this reference, then it will you are trying to create a modifiable reference through non-modifiable function. That is not allowed for the compiler. So if you want to have this this reference of non-modifiable things, for example, this this print function is not supposed to make any changes to the instance variables, compiler will not allow to that. Therefore you cannot, it will not allow you to make a modifiable reference to that that variable. So you need to create constant reference. Okay, but if I remove this constant keyword here, it should allow to create a non-modifiable reference variable. I'll show you after that. First let me show you the outcome of this code. Compilation and execution. So you can see the access data 12 has been accessed. Okay, back to the code. If I don't if I would if I remove constant in both functions, I mean function and the and in this case it will allow me to create this reference variable. Let me show you the output. Compilation and execution, right? There is no problem here in this case. Back to the code. Now I will also discuss some of the cases where you can actually overcome this shadowing, particularly the cases I discussed at the beginning. If you want to access the global variable, for example, I have integer x equals to, let's say 22, and inside main function I have another variable int x equals to 44, and in this scope, if I want to access global variable, there is something called global namespace. So you can use global namespace to actually specify the scope of the variable, and it will allow you to display that variable x. So the way of doing that is put this scope resolution operator before the name. So it will actually access this x variable, this not the variable that is defined in the main function, but it will access the variable in the global scope. Okay, let me show you how it will look like and while I execute. This is a warning unused variable, so since x is not used, so it is warning, so I'm going to ignore this warning. Let me execute. So now that value 22 has been accessed from within the main function, which was actually defined in line 22. Okay, despite the fact that we have another variable with name x with value 44 inside the main function. And but the recommended approach is try to avoid you should try to avoid using the same name in different scopes if possible. That will relieve you from a lot of potential problems, right? So if you have one variable name in the global scope, it is recommended that you use a sort of different name in the local scope in the situation where you actually want to access the global variable, right? Similarly, if you have a variable with some name in the main scope, in the local scope, then you would you are actually recommended or suggested to use a different name in the block scope, right? Those are few suggestions that you can use, few tips you can use to overcome the problem of the shadowing that comes up. Now, having discussed the shadowing and the shadowing in the class functions, I will discuss shadowing in inheritance. Okay, so let me jump into the code. I want to actually clean this up to explain the shadowing and inheritance. So all the cases of shadowing that I discussed before, they actually apply. They can be they come up, they may come up. That applies in the inheritance as well. But I'm going to be discussing a special case, a case that is actually specific to the inheritance structure or relationship between the classes. So for that, I need to create a class. Let me create a class called person. And to make it simple, I am not having any attributes here. Right, this is a person class, and I'm going to have another class, student, actually publicly derived from person class. So in the person class, I have, let me have class name function to actually display the text called person. All right. So, and I also want to have the similar function in the derived class to display the class name. Now, let me have a print function, and which actually calls class name in the base class. And in this case, this print function is going to be automatically inherited by the student object, student class. So if I create a student object, and I try to I can call print function through this object, because this has been inherited, but it will actually call this person version of this class name function. Okay, first let me show you the output of this code. Now it has displayed the text person. Right, now if I have let's say similar print function in the derived class, it will obviously call the student version of this statement. This statement in line 33 will obviously call the student version of the print function, and I mean, it makes sense to expect that this invocation will call the student version class name, obviously. Output, compilation, and execution. So student has been displayed. So now if I want to actually access the base class version of the print function, I want to call base class version of the print function. Or let's say I want to, from this derived class, let me for a moment let me remove this base class of the print function. Okay, I actually want to call the base class version of this class name from the derived class, right? So let me explain it again. From the derived class functions, if any function or any member function is invoked, and if the base derived class and base class have the function with the same name, then it will go for the derived class function name. That is called shadowing. Derived class name function is actually shadowing the base class class name function. That means it is not making it available, right? So this applies even if I have a function with a different signature in the base class, right? For example, if I want to this function to accept two characters, character 1 and character 2, and put these characters before and after the text that is to be displayed. Right, so this is one function. This is the function with the same name but different signature. Even if we have the function with different signature and I try to call the function with that signature, let's say I want to put this character on the left side and this character on the right side. Okay, so there is going to be issue here, problem here, right? First, let me compile, show you the output, and I'll discuss it further. So now you can see the error, no matching function call for a student. So it actually looks for the function with this signature in the derived class. It doesn't go and look for the function with that signature in the base class. Okay, so this is another effect of the shadowing. If you have a class with the same name in the base and derived classes, then it doesn't actually inherit. It actually, the derived class version of the function actually shadows the base class function regardless of the signature of the function, right? So to overcome that shadowing, and obviously you can actually call specific, you can be specific in calling the base class version of the function. For example, if I want to call base class version of class name, then you can prepend the function name by this scope resolution operator, and you can further prepend it by the name of the base class. Okay, so this is the way of actually overcoming this problem. Or another way is you can have a different name itself. If there's a same name in base and derived class, either you explicitly call the base class version of the function, or you can use a different name in base and derived classes. Compilation and execution, right? So it is compiling, executing, printing the person in more desired formatted way. Okay, this is the end of the video. I discussed shadowing and shadowing in member functions and also shadowing in inheritance. Thank you for watching.